combination of cells. We will be looking into three combination of cells. Our first combination of cells is in series. A very important diagram to take care of note of. Total EMF, I'll take it to N, I'll get NE. Total internal resistance is NR, and total resistance is R plus small r, which is equal to R plus NR. On substituting using the Ohm's law, I is equal to VR, where V is equal to NE and total resistance is equal to R plus NR, as this the formula which we will be getting up. And when is this combination used? This combination is used when external resistance is larger compared to internal resistance. There are also a few special cases. If small r value is very less than capital R, small r can be assumed to be 0, thus giving us I is equal to NE upon R. And if small r value is greater than capital R value can be assumed to be 0, thus giving us I is equal to E upon R. Let's take a second case of it being connected in parallel with this setup. Total EMF would now only be equal to E. Total resistance. Now we all know when resistance is connected in series, it is R plus R. But when the same resistance is connected in parallel, it is in this form. So same, our total internal resistance would be in somewhat this form, which will give us N upon R. And to find, we have to inverse its value. So it would now be as R by N, and total resistance would be capital R plus R by N. Using Ohm's law, we'll substitute value of E as here and total resistance as here, on which further solving would give us NE upon NR plus small r. Now when is this combination used? This combination is used when external resistance is smaller compared to internal resistance. Looking into a few special cases, this small r is extremely smaller than capital R small r can be assumed to be 0, thus giving us this formula, and R is greater than capital R can be assumed to be 0, thus giving us this formula. Hence, if you notice, like the difference between series and parallel and even the special conditions is they are both opposite. Hence, you can use that factor and make it much more easier to remember. Moving on to the third combination, that is mixed grouping, in which we've got a massive mega setup in which they were in first three, they were either only this part or this part, but in this case here it is a mega combination of all these three parts. We've got rows, we've got number of cells and all that. So our EMF is NE. Our total internal resistance here in this case, however, is 1 upon NR plus 1 upon NR to M rows, is giving us M upon NR. Now to find the actual value, we have to reciprocate it, thus giving us small r as NR upon M. Total resistance as R plus NR upon M. Using Ohm's law, substitute value of E, NE and small resistance, thus giving us this value. On further substituting us will give us this value, which you can derive from the table down there. This condition is specifically used when external resistance is exactly equal to the internal resistance. A special case when MR is equal to NR, your R value would be equal to NR upon M.